Bismillahirrahmanirrahim. Sallallahu alayhi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of S1 variant 53 of June 2021. For this lecture, I am using the work of one of my best students, Miss Sania Ijaz of class 2022, the Lyceum. Well, all these instructions are very important, especially this last one. Give non-exact numerical answers correct to 3 significant figures. Must follow all these instructions. An important tip, avoid careless mistakes. Question number 1. The heights in centimeter of 160 sunflower plants were measured. The results are summarized on the following cumulative frequency curve. Part A. Use the graph to estimate the number of plants with heights less than 100 centimeter. So this is 100 centimeter. So we need the corresponding value of 100, which is 60. So there are 60 plants of height less than 100 centimeter. That's the answer of part A. Part B. Use the graph to estimate the 65th percentile. So we need P65. For that we need to take 65th percent of total frequency first. So 65th percent of total frequency, which is 160, is 104th observation. So we just need to find the corresponding value of 104th observation, which is 136. Therefore, this is the answer of P65. So P65 is 136. The corresponding value of 104 is 136. Part C. Use the graph to estimate the interquartile range. This is so simple. For Q1, we need to find 25% of 160th observation. So 25th percent of 160 is 40th observation. Therefore, 40th observation will be Q1, which is 76. So Q1 is 76. This is Q1. For Q3, we need to find 75% of 160th observation, which is 120th observation. So 120th observation is 150. This is 150, and this is Q3. So Q3 is 150, whereas Q1 is 76. According to this formula of IQR, we have 74. The IQR is 74. This is the answer of part C. This is Q3 and this is Q1. The difference of these two will give you IQR, which is 74. Question number 2. The random variable x can take only the values. The probability distribution of x is given in the following table. You all know sum of all the probabilities is always 1. Given that probability x greater equal to 0 is equal to 3 times probability x less than 0. X greater equal to 0 means these 3 probabilities, this, and this. So you need to write these 3 here, sum of these 3. 0.1 plus q plus q. So 0.1 plus 2q will give you this answer. This is here. And this answer is 3 times probability x less than 0. X less than 0 means these two probabilities. Probabilities of -1 and -2, which is 2p. So 3 times this probability means 2p. So this equation will give you this equation. This information will give you equation number 1. This is equation number 1. So with the help of this information, we have made equation number 1. And by adding all these probabilities and equating to 1, we can get the equation number 2. So this is equation number 2. By solving these two equations simultaneously, we can get the values of P and Q. So P is 1 upon 8 and Q is 13 upon 40. In up to 3 significant figure, Q is 0.325. You can leave your answer as a fraction. So with the help of this information, we got equation number 1, and we all know sum of all probabilities is always 1. So with the help of this information, we got equation number 2. By solving these two equations simultaneously, we have got the values of P and Q. Number 3. A sports club has a volleyball team and a hockey team. The heights of the 6 members of the volleyball team are summarized by sigma x and sigma x square. Well, the heights of the 11 members of the hockey team are summarized by this sigma y and sigma x y square. Part A, find the mean height of all 17 members. This means we need combined mean, and this is the formula of combined mean. Sigma x plus sigma y divided by total number of players. This is the exact answer, and this is the answer up to 3 significant figure. You can leave your answer in both the ways, but make sure you will use this value in the later part. Never use this estimated answer in the later part. Find the standard deviation of all 17 members. This is the formula of the combined standard deviation. Sigma x square, sigma y square, n1 plus n2, and combined mean. And we will use this number here instead of this number. So combined mean is this, and sigma x square is this, and sigma y square is this, and n1 plus n2 is 17. Make sure you will give your answer as a 3 significant figure. Question number 4. 3 fair 6-sided dice, each with faces 1, 2, 3, 4, 5, 6. Since all dice are fair, so probability of all the numbers are same, 1 upon 6, 1 upon 6, and so on, are thrown at the same time, repeatedly. For a single throw of the 3 dice, the score is the sum of the numbers on the top faces. So this is the way to get the score. Part A, find the probability that the score is 4 on a single throw of the 3 dice. So there are 2 methods to solve this question. This is method number 1. We just need to check the options, the possible scores. So these 3 scores will give you sum 4. So if the scores on all 3 dice are these 3 numbers, like 1, 1, 2, so we will get total score 4. And this order is random. We can have this option 1, 1, 2, 1, 2, 1, 2, 1, 1. Since this order is random, so we need to multiply this result with 3 factorial over 2 factorial, because we have 2 same numbers. Since all the dice are fair, so probability of all the numbers should be 1 upon 6 each. So 1 upon 6, 1 upon 6, 1 upon 6. And this result is 3. So the final answer is 1 upon 72. This is the first method, and this is the second method. Instead of multiplying this with 3 factorial over 2 factorial, you just need to list all the possible ways of getting the score 4. So 1, 1, 2, 2, 1, 1, 1, 2, 1. Probability of this is 1 upon 6, 1 upon 6, 1 upon 6. Same is here, 1 upon 6 cube, 1 upon 6 cube. Since we have 3 ways, so multiply either this answer or this answer with 3 to get this answer. So you can either use this method or this method. Both methods are right. Next part. Find the probability that a score of 18 is obtained for the first time on the 5th row of the 3 dice. This situation is of geometric distribution. This is geometric distribution. and probability P is unknown. To get this probability, we have to use this information. Score 18. To get score 18, there is just one way. All three dice must show 6. So, if all three dice will show 6, then we will get 18. So, the probability of 18 is 1 upon 6 cube power 3, because all numbers have same probability, 1 6 1 6 1 6, and this will give you 1 upon 6 cube. So this is P of the geometric distribution. Now we need this thing, 18 first time on the fifth row. So on the fifth row means this is the formula of the fifth row of geometrical distribution, q power 4 times p. This is here, q power 4, p is 1 upon 216, therefore q will be 215 over 216. So q to the power 4 times p power 1. And make sure you give your answer up to 3 significant figures. Next question, number 5. The lengths of the leaves of a particular type of tree are modeled by a normal distribution. A scientist measures the length of a random sample of 500 leaves from this type of tree and finds that 42 are less than 4 centimeters. So less than 4 centimeters are 42 out of 500, and 100 are more than 10 centimeters. So more than 10 centimeters are 100 out of 500. So when you will convert this statement in the form of Z, you'll get this thing. And this probability will give you this thing. This is the value of 1.378, because this area is here. Less than 4, this number is, this probability is less than 0.5, so this is the required region. This probability is here. And the value of Z1 is this. So this is, this information will help you to form equation number 1. This probability is, I guess, 0.1. This is here. Let me correct this. Point 1 is a very small probability, so it should be here. This is Z2, and this probability is 0.1 approximately. And the value of Z2 is 0.8416. This value is minus 1.378, and this value is 0.8416. So this information will help you to form equation number 2. And by solving these two equations simultaneously, we can get the values of mu and sigma. Hence, sigma is this and mu is this. Make sure you shade the required region correctly. Part B of this question. The lengths in centimeter of the leaves of a different type of tree have the normal distribution. The scientist takes a random sample of 800 leaves from this type of tree. Find how many of these leaves the scientist would expect to have lengths in centimeter between this and this. This is so simple. When you will simplify this, when you will convert this statement into Z, you will get this thing. Like this minus mu over sigma, this minus mu over sigma. So you have to cancel these two mu's and this sigma with this sigma. So you'll get this thing. and this is phi 2. Since this is negative, so it should be minus bracket 1 minus phi 2. You need this probability. Hence, this is the probability. This is this area, this probability. And there were 800 leaves, so expectation means n times probability. This will give you expected number. 763. Make sure you give your answer as a whole number. Never write 763.0 or 763.4. Always give as a whole number, because leaves are discrete quantity. Don't leave your answer in this way. 763 as the final answer. Next question. Number 6. How many different arrangements are there of the 11 letters in the word requirement? I mean, 2 letters are repeated, 3 E's and 2 R's. So 11 factorial divided by the repetition. 3 factorial for 3 E's and 2 factorial for 2 R's. So these are the total number of ways. Leave your answer as it is. This is the exact answer. Part B. How many different arrangements are there of the 11 letters in the word requirement in which the 2 R's are together and the 3 E's are together? So 2 R's should be here, 3 E's should be here, and the remaining letters are 6. So these are 8 objects. This is object number 1, this is object number 2, and these are 6 objects. So one object and 6 objects. This will give you total 8 objects, so 8 factorial. And there is no need to arrange 2 R's and 3 E's, because there is just one way to arrange identical objects. For 2 R's you can write 2 factorial, which is 1. So just leave it. So one object and 6 objects. So altogether 8 objects. That is why we have 8 factorial here. And this is the exact answer. Next part. How many different arrangements are there of the 11 letters in the word requirement in which there are exactly 3 letters between the 2 R's? This question is very important. 3 letters between the 2 R's. So we have to make all possible arrangements, that is with and without E's. This is the first way. The first letter is R, the last letter is R, and no E's between R's. See, no E's. I mean, E complement means other letters. So we can have any 3 letters here from the remaining 6 letters. There are 6 remaining letters. So 6C3, we need to write 6C3 for to select 3 letters for these 3 positions. So 6C3 is here. And these 3 letters can arrange themselves in 3 factorial ways. Now, this is just one object. This is one group. So this is one object. And this is object number 2, 3, 4, 5, 6, 7. Altogether we have 7 objects. So we can arrange them in 7 factorial ways. And here we have 3 E's. So we need to divide this result by 3 factorial. Since we have 3 E's here in any way, so we need to divide this result by 3 factorial. This 3 factorial is for these 3 E's. Now, arrangements with 1 E between the 2 R's. So when we have 1 E, then we need 2 more letters from the remaining 6 letters to fit here. So we need to write 6C2. So in 6C2 ways we can select 2 letters for these 2 positions. And since these 3 letters are random, they can arrange in themselves in 3 factorial ways. So 3 factorial for these 3 letters. And we have 2 E's here. So we need to divide this result by 2 factorial. and this is just one object. So this is object number 1, 2, 3, 4, 5, 6, 7. So we have 7 factorial here and 2 factorial for 2e's. Now arrangements with 2e's between the 2 r's. So 2e's, there is no need to write anything for these 2e's since both are identical, so just leave the selection of these two. Now we need one more letter from the remaining 6 letters for the third position. So we can select one letter in 61 ways. Now these 3 letters can arrange themselves in this way, 3 factorial over 2 factorial, because 2 letters are same. And all together we have 7 objects, 1, 2, 3, 4, 5, 6, 7, so 7 factorial. Now we just need to add, and we can have all 3 e's as well. We can have all 3 e's here. So when we have all 3 e's, so the arrangement of all 3 is just 1, and altogether we have 7 objects, 1, 2, 3, 4, 5, 6, 7, so 7 factorial. So there are 4 options and 4 ways, 1, 2, 3, 4. We just need to add all of these 4 ways to get the final answer. So first you have to make arrangements with no e's between the r's, then 1 e between these 2 r's, then 2 e's between these 2 r's, and then 3 e's between these 2 r's. Last part of this question. 5 of the 11 letters in the word requirement are selected. How many possible selections contain at least 2 e's and at least 1 r? So these are the conditions. We need at least 2 e's and at least 1 r, and we need altogether 5 letters. So we can have 3 e's with 2 r's. This is the first way. So no letter is required from the remaining 6 letters, so 6 is 0. Now when we have 2 e's with 2 r's, we need one more letter from the remaining 6, so 61. When we have 3 e's with 1 r, we need one more letter from the remaining letters, because altogether we need 5 letters. This means 4 letters. We need one more letter, so 61. Now we need 2 more letters when we are selecting 2 e's with 1 r, so 62. So these are the ways, 28 ways altogether to select 5 letters with this restriction. Next question, number 7. In the region of Arka, the total number of households in the 3 villages R, S and T is 800. So this total is 800. Each of the households was asked about the quality of their broadband service. Their responses are summarized in the following table. Part A. Find the probability that a randomly chosen household is in Shan and has poor broadband service. So Shan, poor broadband, so 40 upon 800. That's the answer of first part. Part 2. Find the probability that a randomly chosen household has good broadband. So we have to select from these 3. Given that the household is in Shan, so good broadband and Shan, so 177 divided by 440. See, good broadband service, given that the household is in Shan, so this is the denominator and this is the common. You can do this in this way. Probability good broadband intersection Shan divided by probability Shan. So probability Shan, the total number is 440, or you can do this in this way as well. See, N. So NS is 440 and G intersection S is 177. This is the easiest way to solve this question. In the whole of Arka, there are a large number of households. A survey showed that 35% of households in Arca have no broadband service. So this probability is fixed because of the large number of households. 10 households. This question is of binomial distribution now because 10 households, n is fixed. Find the probability that fewer than 3 of these households have no broadband service. So this question is of binomial with n 10 and p 0.35. We need less than 3. For that we need to add 3 numbers, 0, 1 or 2. So 0, 1 or 2. This is the answer up to 3 significant figures. Last part of this question. 120 households in Arca are chosen at random. Use an approximation. Approximation means a normal approximation. Find the probability that more than 32 have no broadband service. So this question is originally of binomial, but we have to do this question through normal approximation. So NP is 42 and NPQ is 27.3. And since this probability is required, x greater than 32, so the first number on number line should be 33. And since we are going on this side on number line, so we have to take the lower bound. The first number is 33. These are the possible integer values, so 33. So we need to take lower bound. Whenever we go on this side, we take lower bound. So 32.5 minus 42 over under root 27.3. So we need this area. This is 5. Make sure you give your answer up to 3 significant figures. And do 2 things carefully. Number 1, continuity correction, and always use number line for that. Since the number is greater than 32, so the first number on the number line should be 33 because this number is exclusive. So whenever we go on this side on number line, we always take the lower bound. The lower bound of 33 is 32.5. And this number should be inside the root. This is NPQ variance. So when you take root, you will get the standard deviation. And make sure you mention under root and NPQ here. That's the final answer up to 3 significant figures. This is all an important advice for me and for everyone. Be careful. Good luck. Allah Hafiz.